In this video, you'll learn about the seemingly complicated Lambda function in just a few minutes. Now, the Lambda function is really just a one-line anonymous function. It's actually fairly simple, it just looks a little bit complicated. Now, let me define one so you can see exactly how it works. So I'm going to make a variable called add1, and I'm going to make this equal to a lambda, and then I'm going to have some different parameters for my function. Now, in this case, I'll just take a parameter x. I'm then going to put a colon, and what I put after the colon is an expression that will immediately be returned from this function. Like I said, it's a one-line anonymous function. The anonymous component means that I don't actually need to assign this a name. In this case, I'm storing it in a variable add1, but I can use it without declaring it as a variable or associating it with some kind of name. Now, if I want to use this function, I can say add1, and I can pass the value 1 to it. We can store that in a result variable, and we can print that out, and you'll see that when we run the code, we get the value of 2. Now, obviously, we can make this a bit more complicated. We could accept another parameter like x and y, and now I can do x plus y. This just means I need to pass another parameter here, and if I save my code and run, you see that now we get the value 8. Lambda functions can accept any number of parameters, and they can return any valid Python expression. Now, just to show you the equivalent function, if we were to do this without a lambda, I could say define add_1. I could accept my parameters x and y, and then I could return x and y. These two lines are actually the exact same thing, and the reason why we would prefer a lambda function is we would define this in a place where we don't need this function definition. So maybe we're never going to use it again, or just passing this as an argument to a particular function. In fact, that's where lambda functions are most useful, when you're using them as an argument and you want to define the function in the place where you're using it, because it doesn't make sense to define it as a standalone function. You'll see what I mean now as we go into the examples of looking at map and filter, which is where the lambda function is most useful. So let's look at an example here where we utilize the map function. Now, what the map function does is take some list or some iterable object and apply a function to every single value inside of it. In this case, what we do is we take all of these numbers, we pass them to this square function, and we generate a new list that contains all of those results or all of those squares. So if I run the code, you can see that we get all of the squares from 1 to 10. Now, this is fine, and in this case, we've used a function that we've defined normally using the def keyword. However, this is really where we would want to use a lambda function because it's a little bit more elegant, and we don't need to use this square function again. It's kind of redundantly defined. We're not going to utilize it again like we would a normal function. So what I can do is remove that and instead place a lambda function directly inside of here. So I can say lambda x, and then x to the exponent 2. Now, this works well because this is a very simple function. It's one line. It's anonymous, meaning I don't need to store a reference to it after we're finished with this. And now when I run the code, you can see that we get the exact same result. So that's really the use case of the lambda function when you need to pass this as some kind of argument, typically to another function. Now, another common use case of the lambda function is with the filter function. Now, the filter function will simply apply a function to every single value inside of some kind of list or iterable object, and if the function returns true, it will keep this item. If it returns false, it will reject it. So it's filtering some kind of iterable object for us. Now, in this case, I've written a lambda function. This takes in the value, x is the parameter, it does the modulus 2 of this and sees if that's equal to 0. Now, really, this is just checking if the value is even, and if it is, it will keep it, otherwise it will reject it. So when I run the code here, you can see now that we get 2, 4, 6, 8, 10, just another very common use where you'll see the lambda function inside of the filter function as the function that's being used to filter the different elements. Now, another instance in which you'll see this lambda function is as the key function for some kind of sort. Now, in this example here, you can see that we have a list and we have a few different tuples inside of here. Now, we have a number, we have a letter, we have a string, and it's kind of ambiguous which element we actually want to sort by or how we should sort these various elements. Now, we can specify exactly how to sort that by passing a key function. Now, in this case, what the key function will do is simply take any one of our objects here and just strip out the element at index 1, which in this case is going to be the letter. This now is the element that Python will sort based on, and it's a very common use case for using this lambda function. So if I run this code here, you can see now that we're going to sort based on the middle element, so the letter. So we have A, B, and C, and that's how the sort was applied. Now we can obviously change this and we can make it more advanced. For example, I could say x1 plus x2 or something along those lines, and then if we had a tie, it would end up sorting by the second string. So now let's save this and run, and you can see that we end up getting 1, 2, 3. So now let's look at a few more advanced examples with the lambda function. Now in order to do that, I'm going to introduce a new function to you called reduce. Now the way the reduce function works is it's going to reduce down some kind of iterable object to a single value. It does that by utilizing a reduce function. Now this function is going to accept two arguments. The first is the accumulated value that we have so far, and the second is the next value that we're going to be processing from our iterable object. Now by default, the accumulated value when we start will simply be the first value inside of the iterable, and then x, or the value we're processing, will be the next one. So as we begin and we're reducing these numbers here, 1, 2, 3, 4, 5, what's going to happen is the accumulator is going to be 1 and x is going to be 2. That means that this function is going to return 3. Now 3 will become the new accumulated value, that's what we have so far, and from 3 we're going to add to that the next value here, which is 3. Now that's going to give us 6. That means the next accumulated value will be 6. From the 6, we're going to add the next value, which is 4. That gives us 10. That means the next accumulated value is going to be 10. So we're going to have 10. We're going to add 5 to that, and we're going to get 15, which is eventually what the output will be. So we've done that using a lambda function that has two parameters. That's all reduce is doing. It's just taking whatever was returned from the last call, passing that as the next accumulator, and then adding in whatever that additional value is that we're processing. Now this is a simple example where we're just adding all of the numbers together, but we also can use this to find the maximum value in some kind of list, which is what we're doing down here. Now notice what I've done in this example is I've actually written an inline if statement, and that's the expression I'm returning from my lambda function, which is totally valid. So I'm saying that I'm going to return the accumulated value if the accumulated value is greater than x. Otherwise, I'll just return x. Now really all that means is I'm just going to keep the largest value that I have. As soon as some value is larger than that, then we'll return that one. Otherwise, we'll keep the previous one because it was larger. Quite simple. That's how we get the maximum value using reduce and using the lambda function. And as a quick last example, feel free to have a look at this code right here. It's completely useless and there's no reason why you would ever write it like this, but this is valid Python syntax and I figured you could have a look at it. All we're doing is defining a lambda function and then calling it directly in line by having the call symbol after the lambda function definition. Again, valid syntax. I don't know why you would do this, but it is something you can do, so I figured I'd show it to you. That's it. That's going to wrap up this video. If you enjoyed, make sure to leave a like, subscribe to the channel, and I will see you in the next one.